Okay, the next thing I want to talk about is host software baselining. And what this is basically snapping a line in the sand, so to speak. We want to install our operating system. We'll install the OS itself, any patches, any tweaks, anything that we need to get the actual OS to a base level of configuration, something that we're going to deploy kind of enterprise-wide as an example. From there, once we snap that line, we can now compare against that to see any changes, whether the benefits or the negative effects of upgrades, patches, or system tweaks. All right, so it's very important that you understand the value of this, because without having a baseline in play and having something to compare against, how can you really understand, are your systems functioning well or are they degrading over time? There's really no way to understand that unless you have something to compare against, so that when you install your patches, your upgrades, you make tweaks to the system, whatever that might be, you can then go back and say, okay, our system is now functioning at 60% capacity, 70% capacity, what have you, or now our CPU is spiking continuously over 80%. Well, was it doing that before? If you don't have a baseline, you don't know exactly how it was performing prior to those changes, prior to those upgrades. So it's important to understand that this historical artifacts, or the historical records of where things came from, allow you to much more effectively manage the environment going forward. All right, so that kind of takes us into virtualization, and it kind of goes hand in hand with that, because we can use virtualization and something referred to as snapshotting, which I'll talk to in a minute, which can help us to understand these baselines and so forth. So in virtualization, we have traditional architecture on the left. We have our virtual architecture on the right. Okay, we've covered virtualization in another module, but to kind of reiterate what we talked about previously, traditionally we had one server, one OS. It's a one-to-one relationship. The applications we installed on top of the OS, which sat on a single server. In a virtualized environment, we have a much beefier server, referred to as a host, and then we have a bunch of guest operating systems. So VMware is the predominant player in this market, but there are others. KVM, Microsoft Hyper-V rather. There are a number of other hypervisors outside of VMware, but we're using them for this example since they're the market leader at this point in time anyway. So with VMware, as an example, we can run multiple guests on top of that one host. Sometimes, depending upon how beefy the server is, and if you have an ESX cluster as an example, you have a couple servers acting in tandem, you can have 30, 40, 50, 60, sometimes upwards of 80 or 100 guests per a single host. So instead of having 100 servers out there, you'll have one beefy server or one cluster, and then you'll have a number of guests sitting on top of that. To the outside world, they appear as though they're physical servers. Okay, they have their own operating system, they have their own applications, they have their own IP addresses, networking, so on and so forth. Okay, all the things that you would expect in a traditional architecture. Now, with virtualization, we have something referred to as snapshots. And snapshots give us the ability to create point-in-time copies of the OS and any applications that are currently running. So we can take multiple snapshots and we can store them to some centralized location. They can be deduped, okay, deduplicated, meaning if they have multiple images that have a lot of the same data, we can pull the data out of those duplicate images and just put pointers in, so they all point to a single copy, and it saves space on that storage device. It can be used for testing upgrades, patches, and adjustments to the OS, applications, and settings. So basically with snapshots, it's a great feature. As a security professional, you should become aware of this as well, because it allows us, right, to go out and create changes or make changes in our environment. We can add security patches. We can do tweaks. We can do whatever we need to do to a specific operating system or an environment. We can snapshot it beforehand. We can make our upgrades. And then if something doesn't work for whatever reason, we can roll back very easily to the point just prior to when we did those changes and those tweaks. Okay, so as an example, here we have basically an ESX server. It could be a cluster, but in this example, we're just showing a single server. We have multiple VMs or multiple guests riding on top of that host, right? Remember the guest and host relationship. So we have multiple guests on a single host. We have snapshots are being taken of those individual guests, and then they're being stored off to a centralized location. Okay, let's just say a storage array. Those snapshot images can be deduped, as we mentioned, but let's say, for instance, as you see on the left, the virtual machine, the first one there, for some reason, something happened to it, either went down or we applied some type of patch or some type of tweak, and it just didn't work out right. Didn't meet our expectations, or something crashed, didn't work. We can recover from that very easily by simply restoring from a snapshot. So it's much like a backup, but it's a point-in-time copy. Okay, it's an application-consistent copy because it snaps the entire OS, the application, everything. The state of that VM at that point in time. We'll copy that over to our storage array, and if something goes down, like I say, we can restore that back and get that virtual machine up and running relatively quickly. So, some things or some use cases where virtualization really comes into play and is helpful for us even if we don't have a large virtualized environment, it still would pay dividends to have a virtual representation of your physical environment. Okay, you can do what's called P2V, physical to virtual. You can take your your physical server, virtualize that, and then test against it. So you can do such things as patch compatibility. Okay, in other words, do the patches work as advertised? Because just because Microsoft or Linux or whatever flavor of Linux you're using, Apple OS, Mac OS, just because a patch comes out, it doesn't necessarily mean it's going to work across the board. It doesn't mean it's going to work with all of our applications. Okay, there's just too many out there to be sure. So you can create a virtualized rendition of that server, test your patches, and make sure that they work. You can do user acceptance testing. You can very easily clone those virtual machines and have a number of instances set up. You can bring in users, a pilot group if you will, and have them test applications to make sure they're actually functioning as advertised. And then we can also do regression testing. All right, has there been a thorough test of a fix or an upgrade? Right, we want to make sure that just because we may be installing a new fix or some piece of new functionality, we have to test to make sure that that doesn't break anything previously. Okay, introducing something new doesn't break something that's already there. Okay, so we don't want to introduce any new bugs. And then another key benefit to virtualization is host availability and what's referred to as elasticity. Okay, so with virtualization, whether we are doing things internally, we may have an on-premise virtualized environment or a cloud, internal cloud, so to speak, or we may actually be using some third-party provider out to a public cloud. We may have some type of hybrid in between, in fact, but we can scale those hosts. So as we need more compute power, as we need more resources, we can scale as needed or contract as needed. So we're not using resources that we don't need, but yet when we do need more, we can spin those up very quickly. So something else just to keep in mind while we're on the topic of virtualization is you want to understand how rapidly can you expand? Can you burst out to the cloud? Can you do it very quickly? Is it a large effort to actually make that happen, or is it on demand? Same thing with contracting. And then the other thing we want to understand is security vulnerabilities, because if there's security vulnerabilities that you're not aware of, that's also going to scale. So just something to keep in mind in this virtualized environment. It's great. It makes things easy. Obviously, we can expand and contract as needed. But if we're not paying attention to the security vulnerabilities within our operating systems and within our platforms, as we scale those things, we're also scaling our vulnerabilities. Amazon Web Services is a good example of a third-party cloud provider that allows you to scale elastically up and down as needed. Okay, you only pay for really what you use. Amazon does a great job. They have a full-time security staff, obviously. So a lot of times the argument can be made, well, cloud providers aren't as secure. Well, that may be true in some instances. However, the argument can also be made that these types of services, Amazon, Windows Azure, there's a number of third-party cloud providers that have a massive IT security staff. Okay, they specialize in security versus perhaps your company or your organization, maybe not as big, or even smaller organizations where they want to have a cloud infrastructure, but they don't have the expertise. So they may have a small internal cloud, or they may have a small public cloud. However, if they're not the experts in managing that security, are you really more secure than if you're turning it over to a third-party provider who specializes and kind of makes their bread and butter off of security? So just something to keep in mind. So another thing to keep in mind with virtualization is such things as security control testing and sandboxing. So with security control testing, as I mentioned, we can spin up virtual machines as needed. We can quickly test security applications and patches, but we can also test at scale to make sure that a specific application doesn't crash if we have 10, 50, 100 hosts, 1,000 hosts hitting against it. So we can spin those hosts up very quickly if needed to test that environment. And then with sandboxing, as the name implies, we create an isolated environment where exploits can be tested and validated. So in that fashion, you can set up a sandbox environment. You can actually introduce viruses or malware or some type of vulnerability, and you can test against it without affecting the rest of your network. So a sandbox is an isolated environment, doesn't touch the rest of your network. Okay, so it keeps production environments secure and also away from potential threats. Okay, in this module, we covered a lot of information dealing with OS and application security. Talked about the different ways and the reasons why we need to harden and lock down our operating systems and also the applications themselves. We talked about host-based security, the intrusion detection systems, why host-based is in some cases better than server-based. And we also talked about virtualization and how that can help us increase our security posture, test effectively, sandbox to test against malware and vulnerabilities without actually harming our production environment. So I hope this module was informative for you. I'd like to thank you very much for watching.